All right, boys and girls, ladies and gentlemen, when they opened the school, they said, you know, what do you want in the school? And I said, well, just give me a classroom, some lab space, you know, a few computers, and then I'd also like an artificial river in my classroom. You know, huge pumps, big enough for kids to get into kayaks and paddle little miniature kayaks around it. Yes, are we picturing this?
Yeah.
Right? And they said no. Okay, they thought about it carefully, and they said, no, we can't have that. So what I've got here is a simulation of the river. So this blue is like the water. Notice I used blue. Right? What else did I do to kind of further enhance the verisimilitude here? Did I put little waves on there? Yeah, I put the waves on there. And then instead of you canoeing on like in whitewater, okay, I've got a little $5 Radio Shack cart that's going to do that instead. Okay? So here's the current, and I've very cleverly arranged to have the current move at a constant speed. And the first thing that we might do, commence the motion of the current, is we might head upstream. And this is a pain because, well, we go really slowly, but downstream is more fun. It's like, ooh, that's fun, right? And, ooh, I like that, right? You know? Like this here, it's like I'm eating lunch. Keep going. I'm eating lunch and I'm going backwards. Okay, there we go. I like that. All right, let's rewind the river. And this is why we endeavor to go downstream whenever we possibly can, yes? Mm-hmm. Yes. Now, isn't it true also, gentlemen, hello, isn't it true also that it should be the case that rivers, God-fearing rivers, should flow south, I think, don't they? Yeah, the Willamette's kind of a commie river, okay? At least in my opinion, I think it's kind of a communist river, okay? But the Mississippi and the Ohio and the Missouri and all these things generally flow south, right? They flow down the map, down into the Gulf. Are you picturing this? Mm-hmm. Yes. Okay. In Canada, however, there's a system of rivers, and those rivers flow north. Did I check that before I planned a trip going south? Or did I not check it? No, we planned a trip, 3 days, on the Namacon River, and we were going to go south into Lac La Croix, yes, and it was going to be through rapids, and the river flowed the other way. Yeah, that's sad. Isn't that sad? Yeah, that's sad. We ended up paddling. It turns out that the canoers, when properly motivated, can paddle up Class 1 whitewater. Standing waves, we can paddle up it. Because the alternative was to portage around it, which is very, very difficult to do when there's not a portage trail. Why wasn't there a portage trail? Because most people go the other way. Right? And so anyway, that's sort of funny. Anyway, so that's the first thing. If I'm pointed this way, say the boat can go 5 miles per hour, say the current is 3 miles per hour that way, then what am I going to be doing with respect to the shore? If I'm going 5 that way, the river is going 3 this way. I'm going 2 miles per hour upstream. And if I head downstream, I will be going 8 downstream. That's why it's so much more fun to go downstream, yes? Okay. So we'd be like going, boom, boom, paddling, right? And we'd get to a point where like the river would be speeding up because it would be narrow, and our canoes would just stop. We'd be paddling like mad, just going boom, 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 and the canoes would be going, boom. And then it'd be like, okay, turbo time, boom, 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 and the canoe would be going, boom, 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 up the thing. But that was easier than unloading the canoes and walking through the woods and everything, right? Okay. Now, the second thing you can do with a canoe is you can try to cross the river. Now, most of the time we don't do that with the canoe. We're traveling along the river. Okay? So these maneuvers are called ferries. Okay? And the simplest one is that we just head straight across. So watch this. Start the motion of the river. Okay. Not quite so fast, river. There we go. Okay, now, it looks weird, doesn't it? He's like running out of space to walk. It looks weird as you watch it, okay? It looks really strange, and the reason that it looks strange, well, why does it look strange? What's weird about the way it's going across the river? Yeah, it's pointed this way, yes? But which way is it actually moving? It's moving this way, yes? Now, we all understand what's going on here. We look at this thing and we say, it's moving this way, but the paper is moving it to the side. It's doing both velocities at the same time. In fact, this is the best way to explain a velocity with respect to the components, right? There's a component across, that's the speed of this. There's a component downstream. That's the speed of the current. What do we do? Okay, so we've got two speeds. We put those together, we get this sort of thing that looks like that. We understand that it's not actually doing this, which would require like drifting sideways, that it's just rolling on the paper this way. The paper's moving sideways. Now, have you ever seen an airplane doing the same thing? Look for this at the coast. You'll see an airplane, and it looks like they're not flying straight into with the wind, right? It looks like they're sort of moving like this. This is an airplane. The airplane's going like that. Watch for it. Have you ever seen that? Has anybody ever seen that? Look for it. You especially see, you can't be like a 747 up at 30,000 feet. You wouldn't know. Okay? Look for small airplanes that go like maybe 90 miles an hour is fast for one of them, right? A small airplane traveling in really windy, like at the coast. When you watch them going up the coast, right? Okay? You'll see them do that, and of course what they're doing is they're flying this way, but there's a crosswind, and the airplane is. So if you have a 30-mile-an-hour crosswind and you're going 90 miles an hour that way, well, you see it, right? To be sure, airplanes fly through the air they're going through straight, okay? But if the air is moving to the side, it might look like they're doing that, like kind of going off at an angle. Now, what do you have to do if there's a crosswind like this, but you want to fly that way? What do you have to do to go? Or the boat? What does the boat have to do if it doesn't want to go downstream?
Angle.
You have to angle it, okay? Now, I'm like a computer, okay? I can look at the motion of that river and I can compute the exact angle I need to place it on there so that it goes exactly straight across, okay? And this is just an amazing thing. I have to show you this, okay? You guys ready for this? Start the river motion. Oops, that one's a little bit. Here, try it. Kelsey knows how to do it too. A little more toward me. There you go. Good. Look at that. Straight toward me. It's amazing. Isn't that amazing? Okay, it was all Jenny. We practiced this beforehand. Okay, she was just sitting there adjusting it. Yeah. Okay. So if you look at that maneuver, and if this is, are there any people here that learned whitewater canoeing? You learned how to do a ferry maneuver? No, I didn't learn a ferry maneuver. This is one of the things we learn how to do when we're canoeing. But basically, if I'm like this, okay, my velocity is this way. That means I've got an across component. That's what you see. That's all you see. Can we be quiet, please? Okay. So we've got an across component. We also have an upstream component. Why don't we see the upstream component? Yeah, it cancels out. That's canceled out by the current. Yes? Okay. So all she was doing was just adjusting her speed so that it would go straight across the river, which is, of course, what you do when you're actually canoeing. Okay. The other thing you can do is you can also kick a compass and a protractor and a calculator and operate the calculator with your toes as you're paddling, right, and calculate what that angle has to be. I'll show you how to do that. And we would always do that, you know, operate the calculator with our toes, and we get the protractor, and, you know, it's not very hard. I'll show you. Okay. Now, what was the final thing? Okay. This maneuver, if this is a canoe, this is called an upstream ferry. Right? The fact that we point our canoe upstream like that, and then we go like this. And you use this for, in a canoe, you come down, and there's like a hydraulic here, or a rock, or something that you don't like, a waterfall, for example, right? And you want to get your canoe to this side of the river, presumably with an upstream ferry. What you would have to do is you'd have to come down here and go, ooh, I don't like that, right? Flip the canoe around, right? And then go like this. Flip the canoe around, go downstream, okay? Nobody ever does that. But the only time you ever do like upstream ferries is if you want to get onto like a nice standing wave and surf on it, okay? Everybody, do you know what I'm talking about? Has anybody surfed whitewater? You just get yourself on the upstream side of a standing wave, and you can just do crazy things. It's really, really fun, okay? In fact, there's places up in the, remember when you saw the slideshow with the kayaking in Alaska? South of southeastern Alaska, there's places where people go, and the tide sets up 10-foot tall standing waves, and people will kayak on those things, okay? But anyway, what you really do is you come down here, and you don't like what you see. Everybody starts paddling backwards. The bow paddles backwards, the stern paddles backwards. You angle the canoe like this. Paddling backwards, you maneuver the canoe across and maneuver like this. Why is it a bad idea to go and turn all the way around?
You're facing the right way?
Yeah, it's hard to look over your shoulder and see where you are, right? This is